study about science and technology part first. But before that, do subscribe my channel and click the bell icon for notification. Chapter 5 Heat. In the last videos, we had already studied about latent heat, regulation and anomalous behavior of water. In this video, we are going to study about dew point and humidity. We all know that about 71% of Earth's surface is covered with water. Due to constant evaporation of water, water vapor is always present in the atmosphere. This water vapor present in the atmosphere helps us to understand the state of daily weather. The presence of water vapor in the air makes it moist. The moisture in the atmosphere is called humidity. For a given volume of air at specific temperature, there is a limit on how much amount of water vapor the air can contain. If the amount exceeds this limit, the excess vapor gets converted into water droplets. When the air contains maximum possible water vapor, it is said to be saturated with vapor at that temperature. This means that when the limit is exceeded, then air is said to be saturated. The amount of vapor needed to saturate the air depends on temperature of the air. If the temperature is low, it will need less vapor to saturate the air. For example, if temperature of air is about 40 degrees Celsius, it can contain 40 grams of water vapor per kilogram of dry air without condensation. If the amount of vapor exceeds this limit, the additional vapor will condense. However, if the temperature of the air is 20 degrees Celsius, it can contain only 14.7 grams of water vapor per kilogram of dry air without condensing. If the vapor contained in the air is less than the maximum limit, then the air is said to be unsaturated. Suppose unsaturated air at a certain temperature is taken and its temperature is decreased. A temperature is reached at which the air becomes saturated with vapor. This temperature is called dew point temperature. The vapor contained in the air is measured using physical quantity called absolute humidity. The mass of the vapor present in the unit volume of air is called absolute humidity. The general absolute humidity is, however, measured in kg per meter cube. The feeling of humid or dry nature of air not only depends on the amount of vapor in the air, but it also depends on how close the amount is for making the air saturated with vapor. It means that it depends on temperature of the air also. The ratio of actual mass of vapor contained in the air for a given volume and the temperature to that required to make the air saturated with vapor at that temperature is called relative humidity. We can express relative humidity by the formula percentage relative humidity equal to actual mass of water vapor contained in the air in the given volume upon mass of vapor needed to make the air saturated in that volume into 100. The relative humidity at dew point is 100%. If the relative humidity is more than 60%, we can feel that the air is humid. However, if the relative humidity is less than 60%, we feel that air is dry. During winter season, you may have observed a white trail at the back of the flying plane in the clear sky. As the plane flies, the vapor released by the airplane engine condenses and forms clouds. If the surrounding air is having more relative humidity, it takes a long time for the white trail formed by condensation of the air vapor to disappear. If the relative humidity of the surrounding air is less, either the size of the white trail may be small or it may not even get formed. Through these two observations, we sense that the presence of the water vapor in the atmosphere. When air cools due to decrease in temperature, it becomes saturated with water vapor. As a result, the excess water vapor gets converted into tiny droplets. The dew point temperature is decided by the amount of vapor in the air. Unit of heat. The unit of heat are joule in SI unit, calorie in CGS units. The amount of heat necessary to raise temperature of 1 gram of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called 1 calorie heat. Similarly, the amount of heat necessary to raise the temperature of 1 kg of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called 1 kilocalorie heat. It is clear that 1 kilocalorie equal to 1000 calorie. If we heat 1 kg of water by 1 degree Celsius in different temperature range than 14.5 degrees Celsius to 15.5 degrees Celsius, the amount of heat required will be slightly different. It is therefore essential to define a specific temperature range while defining the unit of heat. Calorie and joule are related by following relation, that is 1 calorie equal to 4.18 joule. Specific heat capacity. In order to understand specific heat capacity, let's perform an activity using materials: a tray with thick layer of wax, solid spheres of iron, lead and copper of equal mass, burner or spirit lamp and a large beaker. Procedure: take 3 spheres of iron, copper and lead of equal mass as shown in figure 5.8. Put all the 3 spheres in boiling water in the beaker for some time. Take the 3 spheres out of the water. All the spheres will be at temperature 100 degrees Celsius. Put them immediately on thick slab of wax. Now note the depth at each of the sphere goes into the wax. Now what do we observe? We observe that the sphere which absorbs more heat from the water will give more heat to the wax. More wax will thus melt and the sphere will go deeper in the wax. It can be observed that iron sphere goes deepest into the wax, lead sphere goes the least, and copper sphere goes to the intermediate depth. This shows that for equal rise in temperature, these 3 spheres have absorbed different amount of heat. This means that the property which determines the amount of heat absorbed by the sphere is different for 3 spheres. This property is called the specific heat capacity. Thus, the amount of heat energy required to raise the temperature of a unit mass of an object by 1 degree Celsius is called the specific heat of that object. The specific heat capacity is denoted by letter small c. The SI unit of specific heat is joule per degree Celsius per kg and CGS unit is calorie per gram per degree Celsius. Here, specific heat capacity of few substances are given. If specific heat of an object is C, the mass of the object is m, and if temperature of the object is raised by delta T degree Celsius, the heat energy absorbed by the object is given by mc delta T. In the same way, if the specific heat of an object is C, the mass of the object is m, and if the temperature of the object decreased by delta T degree Celsius, then the heat energy lost by the object will be mc delta T. Heat exchange. If the heat is exchanged between a hot and cold object, the temperature of the cold object goes on increasing due to the gain of energy, and the temperature of the hot object goes on decreasing due to the loss of energy. The change in the temperature continues till the temperature of both the objects attain the same level. In this process, the cold object gains heat energy and the hot object loses heat energy. If the system of both the object is isolated from the environment by keeping it inside a heat resistant box, meaning that the energy exchange takes place between the two objects only, then no energy can flow from inside the box or come into the box, as shown in figure 5.10. In this situation, we get the following principle. Heat energy lost by the hot object equal to heat energy gained by the cold object. This is called the principle of heat exchange. Measurement of specific heat. We can understand this by using mixing method using calorimeter. The specific heat of an object can be measured using mixing method. For this, calorimeter is used. You have learned about calorimeter in the previous standard. If a hot solid object is put in the water in calorimeter, heat exchange between the hot object and the water and calorimeter starts. This continues till the temperature of the solid object, water and the calorimeter becomes equal. Therefore, heat lost by solid object equal to heat gained by the object in the water plus heat gained by calorimeter. Here, heat lost by solid object Q equal to mass of solid object into its specific heat into decrease in its temperature. Similarly, heat gained by water Q1 equal to mass of water into its specific heat into increase in its temperature. Heat gained by calorimeter Q2 equal to mass of the calorimeter into its specific heat into its increase in the temperature. Heat lost by hot object equal to heat gained by calorimeter plus heat gained by water, that is Q equal to Q2 plus Q1. Using these equations, if the specific heat of water and calorimeter are known, the specific heat of solid objects can be calculated. This is the end of our chapter. If you have any doubt regarding this chapter, do ask in the comment section below. Do solve all the questions given in your textbook. Do like and share the video. Thank you.